Assalamualaikum. So today we will continue back our lecture with NTU method. So previously in chapter 4 you have learned, let's recall back, you have learned numerous type of heat exchanger. Then we introduce you to falling effect, the corrosion can happen and the surface on the surface falling on the surface. And we also give a general energy analysis, and we have looked at LMTD methods, one method to analyze your heat exchanger, and the other method is called NTU method. So today we will finish up chapter 4 with NTU method and selection of heat exchanger. Sorry. So NTU method. NTU actually stand for number of transfer unit. Okay, so for NTU method, we introduce you to heat transfer effectiveness, epsilon. Okay, the epsilon is equal to heat transfer effectiveness equal to your actual heat transfer rate over maximum possible heat transfer rate. So your actual heat transfer rate Q dot is equal to C heat capacity of the cold stream. Okay, so this is C, capital C is heat capacity. It is the M dot, C is equal to M dot multiplied by your specific heat capacity of cold stream. Okay, same thing. For heat capacity of hot stream is equal to mass flow rate of your hot stream. Multiplied by specific heat capacity of the hot stream. So Q is equal to heat capacity multiplied by the delta of C out minus C in. So remember, it's always high temperature minus lower temperature. So same thing here, TH in is higher than your TH out, so you take the bigger temperature at front minus by the lower temperature. So make sure your answer must be in a positive value. So that is your actual heat transfer rate. And for the denominator, the bottom one, max Q dot max equal to C min multiplied by delta T max, where your delta T max is your highest temperature. So you have 4 temperature, right? TH in, TH out, TC in, and TC out. So you have to take the most high temperature minus by the lowest temperature. So it will be your delta T max is equal to TH in minus TC in. Okay, and to get Q dot maximum heat transfer, you have to multiply by heat capacity of min. So for here, this C min, you have to compare the value of, you have to compare the value of CC and CH and take the minimum reading either of these two. Okay, so why not C maximum? Okay, it is the maximum possible heat transfer rate. Okay, we want to calculate for maximum possible heat transfer rate. So imagine you have a jug of water, okay, and you have a small cup of water, and the capacity of this small cup is only, let's say the heat capacity is only, it can take only 10 kilowatt, and this one is, let's say 100. So the maximum possible that heat transfer you can get between these two is only 10 kilowatt, because this is the maximum that the small cup can achieve. So that's why we have we take the minimum heat capacity here. Okay, so don't get confused. For Q dot max is always C min multiplied by delta T max. Okay, so take note of this. Okay, so next. So you can, once you know your Q dot and Q max, you can calculate for your epsilon. So this effectiveness of heat exchanger will depends on the geometry of the heat exchanger and also the flow arrangement. So this is one example. So later you will look at depending on the type of heat exchanger and the flow, you will have different equations for to calculate for epsilon E. Okay, and the effectiveness relation of heat exchanger is typically involve a dimensionless group. Okay, this dimensionless group is called NTU. Okay, so here NTU is equal to UAS over C min. So you can replace this equation. Okay, you can replace this equation with NTU. Alright. So U is your overall heat transfer coefficient. We have learned it in previously. AS is your total surface area divided by minimum heat capacity. And like just now, heat capacity is equal to mass flow rate multiplied by specific heat capacity. Okay. So here it says the larger the NTU, the larger the heat exchanger. So here, if you have high NTU, your area will also high. So area means larger heat exchanger. And from area, you can also calculate your diameter and also length of your heat exchanger, depending on the case, whether they give you length or whether they give you diameter. And then here we also introduce to capacity ratio small c, where small c is equal to C min over C max. So here just now we have this C min and C max relationship. We can replace this with C. Alright. So now you have what for epsilon is equal to 1 minus exponential of NTU minus negative NTU multiplied by 1 plus C over 1 plus C. So take note, this is only for double pipe parallel flow heat exchanger. So in table 11.4, you actually have many other different effectiveness relation for other types of heat exchanger. So once you know your NTU and your C, small c, capacity ratio, you can calculate for effectiveness relation. Or the other way around, maybe the question will give you E and they will ask to calculate for maybe mass flow rate or area, diameter of the heat exchanger or length of the heat exchanger. So it depends, it can be two cases. Okay. And this one in this plot, sorry it's not clear, but you can refer to the slide. I have uploaded this slide in our U Future folder. So here you have on the, okay, there are types of heat exchanger here. A, parallel flow, B, counter flow, C, one shell pass, okay, D, two shell pass, okay. They have 6 different types of heat exchanger. So on the y-axis is effectiveness and your x-axis is NTU, and the red curve here is your capacity ratio. Okay, so from your NTU and your C, okay, if your NTU is 2, right, for example 2, then C, take which one intercept, and then you can find your E. and either way. If the question gives you E and you calculate for the ratio, you will find your NTU. Alright, so you have to check which graph is suitable for your type of heat exchanger. Okay, next is selection of the last slide for this chapter, selection of heat exchanger. So usually when making proper selection of heat exchanger, so you have to consider several factors, and that include the first one is heat transfer rate, of course, and then cost. Okay, cost is actually related with the just now you see your NTU. If you have high number of transfer unit, your area also will go high. So if your area is high, that means your cost also will go high. Okay, and depending on, of course, type of material, if you have stainless steel, you have higher cost. Okay, anti-corrosion type of material, that one higher cost. And you also need to consider the pumping power, size and weight, type. This one is include earlier in this chapter we learn about function of heat exchanger. What's the purpose of heat exchanger? So depending on the function, you need to select appropriate type of heat exchanger. And other factor include leak type, safety and reliability, and last factor maybe quietness. Okay, so with this we end our chapter 4. So next we will start with chapter 5. That's all. Thank you.